A company that produces socks wants to estimate the percent of the socks produced in a typical week that are defective. A random sample of 310 socks produced in a certain week were inspected. Based on the sample, it is estimated that 12% of all socks produced by the company in this week were defective, with an associated margin of error of 3.62%. Based on the estimated associated margin of error, which of the following is the most appropriate conclusion about all socks produced by the company during this week? So it is estimated that 12% of the socks are defective, but there's a margin of error of 3.62%, which means that the actual percent of socks that are defective can be 3.62% greater than 12 or 3.62% less than 12. So that means the actual percent lies in a range. And we can calculate the upper and lower bounds of that range by adding and subtracting 3.62 from 12. So when we add 3.62 to 12%, we get 15.62%. And when we subtract, we get 8.38%. So that means that the actual percent of defective socks lies in this range. So answer choice A says that 3.62% of the socks are defective. That's not an appropriate conclusion since that is very out of range from this range here. It is plausible that if between 8.38 and 15.62% of the socks are defective. That sounds appropriate since that is the range of the actual percent of defective socks. 12% of the socks are defective. That's not an appropriate conclusion because that does not account for the margin of error. It is plausible that more than 15.62% of the socks are defective. That's also not an appropriate conclusion because the upper bound of our range was 15.62, so it wouldn't be very plausible for the actual percent of defective socks to be higher than this range. So B is the correct answer.